I don't know if Carver's with us. I know John Hopfield's with us, at least on Slack. But it started with Carver. You know, he got an interest in neuromorphic engineering, but he came directly from device physics, where he invented a basic semiconductor device. And then he was the guy, together with Lynn Conway, who wrote the textbook on digital system design. And this was the book for entire Silicon Valley industry, which evolved out of a series of courses that he taught over probably the previous decade. So he had a lot of credo, you know, to say he knew how to do something as a holiday from this. And in the environment of Caltech, where you could walk across the campus and talk to people like John Allman, this is the guy who discovered the motion sensitive cells in area MT and the cells that would signal whether the monkey was seeing an illusion, you know, illusory stimulus like a Necker cube. So it was an environment where you could just go chat to people who were top experts and get ideas. And using his reputation, he landed a big grant from the so-called System Development Foundation. System Development Foundation was kind of a weird little RAND defense money spinoff that basically funded basic research. He landed a 5 years unrestricted funding grant to fund his ideas, you know, his dream of working on neuromorphic engineering. And it didn't hurt that he was foundational in establishing the MOSIS, the metal oxide semiconductor implementation service, which offered an amazing thing, which everybody would just kill for nowadays, was basically unlimited free silicon. And so in this environment, Carver had a lab full of experienced electrical engineers, but to start working on neuromorphic engineering, he recruited a young biology student, didn't know a thing about transistors. Misha didn't know a thing about transistors, but she was a very, very smart and especially very creative. And Carver and Misha were really my father and mother. You know, Misha was my mentor in the lab. And so I kind of grew up in this whole era of Misha. And so I'm going to tell you a little bit more about that. So here's Carver and Misha. I think this is a picture from Rodney Douglas in Carver land, physics and computation, when they were working on the silicon retina development that you've heard a lot about before. During Misha's PhD work, even before she graduated, she got the cover of Scientific American with the Silicon Sees a Cat. And later on in her PhD, she got the cover of Nature with joint work with Rodney Douglas on the silicon neuron that I think Terry's mentioned earlier. It's the first silicon neuron, unlike Carver's axon hillock circuit, which is a very practical integrated fired neuron, just get switch cap integrated fired neuron. This thing implemented all the basic conductances of the Hodgkin-Huxley model. And I remember Rodney very proudly carrying around a hand-wired, wire wrap board where you could play around with potentiometers and play around with the behavior of this spiking neuron. As a result of not just this work on the silicon retina and the silicon neuron, but the other work, which I'll talk about in a moment, Misha got the well-deserved 1993 PhD award of the Clauser Prize for the best overall PhD thesis at Caltech. And that work was not based on silicon retina, not based on silicon neuron, but instead was actually based on the stereo system that she built. Here you can see the stereo system with two silicon retinas with big parallel cables connecting them to this chip in the middle. And I guess you can probably guess what that chip is, right? It looks like this. Basically, it took AR input from the two retinas and then did correlation between the two input along lines of vision. And this is Misha's stereo system. And I am happy to present another short slideshow of a talk I gave some years ago about how this works. I don't have time to explain it, but for me, this is a very beautiful example of representation, because in Misha's stereo chip, she did kind of a dance between place and value representations, and the whole thing did a beautiful collective computation of stereo matching, which also incorporated models of the different kinds of binocular cells that you see in the binocular vision system, the near and far cells, the tune cells, the inhibitory cells, the monocular cells. It's a very lovely story. It's a little bit hard to understand, so it's good if somebody tells you about it. But if people are interested, I can put together a talk about that separate. But I'm just gonna now play another video from Misha for you. But before I do that, I just want to show you that in Misha's PhD thesis, which is available online, the foreword of her PhD thesis is the following: the manifest unity of our perceptions belies the indeterminacy of our sensations. What does that mean? The manifest unity of our perceptions belies the indeterminacy of our sensations. Basically, she was just fascinated by the idea that we feel like everything is completely unified and put together. And yet, if you look at the sensory input, everything is very, very undetermined in the auditory input and the visual input. And she was consumed by the idea how you can infer what's out there from this incomplete information. And so now you can hear a little bit about that in this little clip that I collected, which I think, for me at least, brings out Misha at her best at work. I hope you can hear
Stereo is an interesting problem because
I probably didn't share the screen. I'm just going to share the screen here once more in a proper way, so that it also shares the audio. Yeah, I think it's okay. Okay. Is this coming across okay or not?
Tobi, you had it before. Now it's not.
Now is it shared?
No, Tobi.
Nope. Do you see the screen or not?
No.
Okay, I'll attempt to share the screen once more. I'm sorry about these problems. Now I'm going to share screen 2. Now you should see the screen 2.
Yes.
Yep.
Okay.
stereo is an interesting problem because it's something that happens in the brain. By the time you get into cortex, you see a lot of activity resulting from the cortex itself. The brain is imagination. And that was exciting to me. I wanted to start building a chip that could imagine something. And stereo is the first and simplest problem where it's very clear that something is being imagined. There were 3 different video monitors that were used, one for each eye and one for the stereoscopic depth computation. Oscilloscopes, power supplies, voltage meters, 2 large tables full of equipment with blinking lights, and then the chips that I had built myself, which were by and large held together with wire tied in random places on the proto board and sort of loose ends hanging off every which direction. One of my retina chips was quite touchy. The design wasn't ideal, and if you apply the wrong voltages to the chip, it has a tendency to latch up, which means it gets very hot. Sometimes it melts. It's a bad thing. And these chips were so delicate that even though they had sent me 20-odd copies of the chip, I only had 2 left. And I needed 2 to do the demonstration because I was doing a binocular stereo demonstration. And I turned the power supply on, and there was a loose wire. The chip got really hot, and I thought, oh no, I've ruined it. This is the last chip, and it's never going to come alive again. But I took it out, let it cool down, put it back in, and it was fine. But it was the most harrowing moment. Your heart just...
Okay, your heart just pounds. Okay, so anyway, the Misha Mahowald Prize recognizes outstanding research in neuromorphic engineering worldwide. It's sponsored by a number of companies. Actually, we're looking for sponsors, right? Actually, financial sponsors to help, increase the monetary value of their award. Right now, it's administered by any forum. The prize selection jury, which is completely in control of who gets the prize, consists of Steve Ferber, University of Manchester, Dan Hammerstrom, formerly at DARPA, Dharmendra Mota, IBM Research, Almaden, True North, Eric Yu, a master at Samsung Electronics in charge of event camera DVS developments there, and Terry Sonosky, who's the jury chair. Previous members have been Sue Denham and Christoph Koch. And I thank the jury for taking a look at all the applications every year. So I'm just going to briefly review the history of the award. In 2016, the award was given to the IBM True North project, led by Dharmendra Mota. And you can recognize a lot of the faces here, a lot of the names like John Arthur, Paul Marola, Chichi mentioned early, Andrew Cassidy, Rodrigo Alvarez, and Rajet Manohar, who were former Telluride participants. In 2017, the prize was awarded to Event-Based Vision for Autonomous High-Speed Robotics. That's the team led by Davide Scaramuzza with Guillermo Gallego. I know Guillermo's with us here. And they also did a nice job to get that award. In 2018, there was no award, but in 2019, the Misha Mahowald Award has been awarded to, be a drum roll, to the Astrosite, a mobile neuromorphic space situational awareness observatory, to the team of Greg Cohen, Colin Symons, Karki, Darren Maybour, Nick, Nick, Ralph, Saeed, Afshare, and André von Schaik at Western Sydney University. And here on Friday, you'll hear much more about Astrosite, but here's Greg Cohen from Western Sydney University in Telluride in 2017, doing some experiments outside the schoolhouse late at night. It's probably about midnight here, trying to collect some data from a DBS and a laptop. And here he is just today, I think, showing off the placard down in Sydney, Western Sydney. And so I just see Friday for more complete story, but here is a slide about Astrosite. On top of that, I'm going to put this video, because it's now about 3:30 in the morning there in Sydney. I prevailed on Greg to record a video, thanks, which I'm now going to play for you on top of this video. So I hope you can see this. Can you see Greg there?
Yep.
He went out about 1 in the morning to the Astrosite
I'm
and
Greg
recorded
Colin,
this.
calling in for a rather late and cold evening here in Sydney, Australia. Unfortunately, I can't be there in person this year, and in fact, I'm here on campus alone today, staring wistfully into the cold night sky. But I guess that's part of my job now. That said, I'm very excited to be here tonight. It's a great honor for us to win the Misha Mahowald Prize, and we really want to thank the judges, the organizing committee, and the panel for selecting the Astrosite as the winner. I can't tell you how much this means to us. But let me show you around. This is the Astrosite. It's a mobile, containerized telescope observatory that we built here at the International Center for Neuromorphic Systems at Western Sydney University. Track satellites and space junk. It turns out it's suited for space imaging and can do things that you can't do with a normal camera or sensor. For example, we can move the sensor and we can use that motion to see better. What this lets us do is image whilst we move the telescope around the sky, allowing us to follow, track, and detect space objects in a completely different way. This is the advantage of making us far less sensitive to motion, and in fact, motion actually helps us. Usually, we'd sink about 4 meters of concrete in the ground to stabilize a telescope system like the one behind me. But because of how this system works, we can just bump this container down, and by leveraging the neuromorphic hardware, we can just start imaging. Not everyone can move the observatories around like we can. So, why is this important? Well, we're actually reliant on space for almost every aspect of our modern life, from GPS and communications to ensuring your pizza gets to you on time. The problem is that we've been launching things into space for the past 60 years. We haven't done a very good job of cleaning up after ourselves. That means the risk of collision between satellites, space junk, and even crewed space vehicles is becoming a real concern. We need better methods to detect and track satellites and space junk in orbit, and that's where we're using neuromorphic technology to help. And we're doing it right now. We're building a network of these Astrosites around Australia for exactly this purpose. It's an exciting project and it's happening right now. And this project could not have happened without the amazing team that we have over here at Western Sydney University and the support, the trust, and the enthusiasm that we've received from the university itself. It also could not have happened without the support of the Royal Australian Air Force and Plan Jericho. They listened to us, entertained our crazy ideas, and they encouraged us to innovate and explore. So let me please accept this award on behalf of the Astrosite team. Colin, Symons, Darren, Maybour, and Karki. They built this, and they kept it running, and they did it in record time. And after all that and everything I put them through, they still talk to me and put up with me. And it also wouldn't have worked without the tireless effort from Saeed, Afshare, Nick, Ralph, and of course André von Schaik. Research is a team sport, and I'm lucky that I have such fantastic people to make sure that these sorts of projects are possible. And that is why it's a true honor to receive this award. And please, feel free to come and join our lecture later this week. We'll show you how everything works and what we're doing to do space imaging differently. We may even show you a glimpse of our second Astrosite container and tell you the exciting things that we have planned for the future. Thank you so much and enjoy the rest of the Telluride workshop. Good night.
Okay. All right. Good night, Greg. I hope you're sleeping tight about 4 in the morning there. Let me just finish telling you about the Misha Mahowald Prize. The prize award this year is cash $10,000. It's a mission deadline for the upcoming prize is 1st October 2020. Any individual or research group worldwide is welcome to apply. You can directly apply or you can nominate something else, some other project which you think is worthy. It's important that it should be any real, demonstrable, innovative hardware, software, algorithm. Doesn't have to, the class of neuromorphic is very broad, as you can see. The application is just 4 A4 pages. English description of the work, its novelty, potential impact, and performance. It can include images and data, as well as links to relevant supporting documents, papers, videos. Resubmissions of revised applications are encouraged. You submit your application as a hyperlink PDF to prize@mahowaldprize.org. You can see full details at mahowaldprize.org. And if you have any questions about the prize, you should contact anyforum.ch. So I'm very much looking forward, and the whole prize, jury committee is looking forward to your project for 2020. So keep it coming. Thank you.
Fantastic. Thanks, Toby. The people who are on the call who have been to Telluride and spent some of those late nights over the last several years up on top of the mountain, staring up at the stars, or in the schoolhouse trying to image things through a shaky telescope will be really excited to see the extent to which that innovation at Telluride helped lead to some really exciting work happening in Sydney. Our intent is that we will find a lot of the same enthusiasm and excitement, a powerful force for projects coming up at this year's Telluride. So who knows, maybe next year we'll be presenting something that you worked on this summer as the winner of next year's Mahowald Prize.